Question 7. A dog running at a constant speed of 3 meters per second. So this is our initial velocity. Increases its speed to 7 meters per second. So that's the final velocity, 7 meters per second. Upon seeing a lion, if the mass of the dog is 20 kg, so mass 20 kg, the work it does in achieving the new speed is, so they want us to calculate work done. So work done, it is the product of force and its parallel distance. So work done is calculated by the following. Force times distance, or work done equal to mass times gravity times height, or work done equal to half mv squared minus half mu squared. So now it is just the matter of checking what you have on the data. So if we consider the first equation, it is not qualifying, even the second equation. But the third one is qualifying because we have initial velocity and final velocity given. So we are going to use the third equation, which is going to be work done equal to, so we can factorize what is common here. So we'll say half out, then we'll remain with v squared minus u squared. So work done equal to half times mass, we have 20, open bracket, final velocity 7 squared, initial velocity 3 squared. So work done equal to 2 into 2, 1, 2 into 20, it's 10. So now 7 squared Gce 49 minus 3 squared Gce 9. So work done equal to 10, then 49 minus 9 it's 40. So work done equal to 10 times 40, which is equal to 400 joules. So if we check from the solutions given there, it's option C. So the correct answer here is going to be C. We go to question 8. A thermoflask contains a vacuum. What is the purpose of this vacuum? So what we should know first is the vacuum. What is a vacuum? So this is the space where there are no particles. This is the space without particles. Options: prevents A, conduction and radiation, B, conduction and convection, C, radiation and convection, D, conduction, convection and radiation. So conduction, this is the transfer of thermal energy from the region of higher temperature to the region of lower temperature through solids. So it requires a transmission medium. Convection, it is the transfer of thermal energy from the region of higher temperature to the region of lower temperature through gases or liquids. So even this one, it requires a transmission medium. Radiation, it is the transfer of radiant heat from the region of higher temperature to the region of lower temperature through electromagnetic wave. So this one, it does not require any transmission medium. So vacuum prevents heat loss from conduction and the convection, because these two require the gas particles. So it's option B. So conduction and the convection, which is option B. So number 8, it's B. We go to 9. Molecules of a liquid evaporate from a container and the temperature of the liquid left in the container changes. From which part of the body of the liquid do the molecules escape, and what is the effect on the temperature of the liquid left in the container? Okay, so what we should know first is evaporation takes place on the surface of the liquid, not inside the liquid, but on the surface. So let's check now the options. Option A, all parts of the liquid, then temperature decreases. Quite a light temperature will decrease, but it does not take place to all parts of the liquid. So option A, we discard. We go to option B, all parts of the liquid and temperature increases. This is not correct. Only the liquid surface and temperature decreases. Let's check option D. Only the liquid surface and temperature increases. So the correct option here is option C. It takes place on the surface and the temperature will decrease. So number 9, it's option C. We go to 10. The diagram below represents a transverse wave, between which two marked points in the distance equal to the wavelength of the wave. So what we should know is that transverse wave, these are waves where particles vibrates perpendicular to the direction of the wave. Then wavelength, this is the distance at which the wave repeats itself. This is the distance at which the wave repeats itself. So we have to check the points where the wave is repeating itself. So let's check AD. AD, this is just the distance of half a wave, because it should be one complete oscillation. So AD cannot be the correct solution. We go to CG. CG. This is also 3/4 of the wave. It is not complete. We go to BG. BG. So this one is close to wavelength. Let's also check the last one. EF. EF. So option A, option B, and option D, they are not correct. So it's option C. Number 10, it's C. Okay, so for today we are going to end here. This is Mr. Mrenga E. Thank you for watching, and don't forget to subscribe to my channel for more videos in mathematics and science. Then for extras, you are free to call on 0763 34 61 57 or 0977 69 37 54. Thank you.